Okay, we are doing more of what we did last time, which is data sufficiency problems that have work up front. If you were here last time, or if you saw the recording of the last study hall, then you'll know what this means. If not, you can kind of just look at the words, and it's pretty much what the words say. Like most data sufficiency problems, you do the work with the statement 1 and the statement 2, once those are in front of your face. But in today's problems, in whichever way, there's going to be ways, there's going to be a lot of stuff that you can do with the prompt before you even start using the statements. So, and that can mean various things. It might mean literally doing work, like doing steps on the paper, but it might also just mean thinking through various issues and what is not necessary to arrive at an answer. So, okay, here's the copyright notice again. These are all from GMAT Prep. They're all from the free GMAT Prep software, because that's what we have to use as per the request of GMAC. So here is a problem. How about that? Right there. Again, remember where you get multiple choice responses. They're underneath your name in the little pull-down menu that is under the lowercase letter a. This is a data sufficiency problem, by the way. We do assume that you are familiar with the data sufficiency answer choices. But just in case, I can go ahead and post them. Let's see. Data sufficiency answer choices. There they are. I mean, if you're here, you probably have these memorized pretty well, but just in case you don't, there they are. Okay, go for it. Give you a little bit to do this one. Okay, let's try to wrap this up pretty soon. Remember, this is an exam where you cannot not answer the questions. So even if you are just randomly guessing, you should pick one of these choices, because if you have a staring contest with the GMAT, then the GMAT will win the staring contest, and you will lose the staring contest. Okay, we have a very interesting pattern of choices so far. Someone just picked A, which is probably a guess, but before that it was all B's and C's and D's. It was like these seem to be the favorites. But let's take a look. And I mean, remember what today's theme is. Today's theme is that it's problems with upfront work. So you can probably guess that there is some work to be done up front in this problem. Yes, indeed. What is that? I mean, there's a thing in this problem that you should pretty much deal with instantly in the same way every time you see it. Like, what kind of work is there to do up front in this problem? Nobody. Shy crowd. Okay, a couple people are typing. Aha, simplify. Okay, by the way, yeah, so before we even go there, I mean, let's take a moment to talk to the people who are picking this choice right here. This choice. I mean, let's go ahead and talk about that choice quickly. If you're picking choice C, then there's not a lot happening in this problem. Like here, let's for a moment entertain the thought that the answer to this problem might be choice C. It's not, by the way, but let's just think about what happens if you're picking choice C. If you pick C, if you do, which you will find out you really don't want to do that. But if you pick C, then these just become numbers. So this would just be x minus y, which would be 1, 8 plus 20, 28. And then this would be 8 plus negative 20. All right, I mean, okay. So two things about this. Two observations here. The first observation is, number one, this is way too easy. Okay, there's this old bit of wisdom that if something looks too good to be true, it's probably too good to be true. And I mean, notice that way too easy, this looks like it's just a matter of opinion, but this is not a matter of opinion. I mean, this is objective and factual, because you can compare against the first few problems in the data sufficiency chapter. Like, I mean, this is actually an objective criterion. Like, and anything that is substantially easier than the first few data sufficiency problems in OG is not right, not how the problem works. And I mean, because there's not really any problems here that are this trivial. I mean, if you go to the OG and you look at the very, very beginning of the data sufficiency part, the problems are still non-trivial. I mean, I think it's the very first problem, you're already using things like absolute values and signs and squares and stuff. So, I mean, there are no gimme problems. So, yeah, if you think you're just going to have a number and then another number, don't do it. So, I mean, this is a very general observation. I mean, sometimes individual statements are this easy. Like, you will often see problems where either statement 1 or statement 2 is actually pretty trivial. But, so just let's type that there. It's okay for one statement to be this easy. In fact, that happens quite often. But the whole problem will never, ever, ever, ever be this easy. Nope. And then the other observation to make here is that if you pick C, what about this, where by this I mean that? I mean, you're just not even using that. Like, another thing about these problems is that you're going to use all this stuff. I mean, this is a promise. If they give you conditions or facts like that in the prompt, you are going to have to use that. So, I mean, there is a section of the test where you ignore a lot of information. That's the integrated reasoning section. In fact, that's why they made the integrated reasoning section, is because in the rest of the test, at least the way it works now, you don't ignore anything. Like, you will definitely have to use this. If you don't have to use this, something is very wrong. You have to use the facts. So don't do it. If you ever see anything that's this easy and that ignores information, it's not going to be right. And the answer choice that does this is usually choice C. In fact, it is so common that choice C does this that there's a whole type of trap that we have done entire workshops about. So, in fact, we've done 2 study halls on it. Here they are. If you are someone who picks C, you should definitely watch these back episodes. You should watch them. These are from the archived sessions. C-trap. C-trap, what we call it when choice C is way too easy and ignores stuff. If choice C does both of these things, do not pick it ever. Don't do it. Okay. Now that we've gotten that out of the way. I mean, smiley face, if you get what I'm talking about with C not being the right answer here. I'm especially looking for the smiley face from people who actually picked C. So, smiley underneath your name. Okay, I'm getting smileys from everybody else. Okay, there we go. The C pickers too. Yeah, okay, don't do it. All right, now let's talk about how the problem actually works. So, here's the problem. And then, as Sydney pointed out, and as Rumi pointed out pretty much directly afterwards, I mean, yeah, the deal is, okay, let's say that I asked you the following question. Do I weigh at least 400 halves of a pound? I mean, what would everybody in the world immediately do to this? And I mean immediately, before you even start turning your brain on. Yeah, you make this 200, right? It doesn't matter. It doesn't matter that it's in a question. It makes no difference. I mean, if you were reluctant to manipulate the algebra because it was in a question, this example should help show you why that's not something to be afraid of. I mean, you just simplify right away. You simplify before you even start thinking. This should be exactly the same thing. Like, I mean, just you should be doing this. You should simplify things like this as immediately as you would simplify something like 400 halves. You should. I mean, this should be every bit as instinctive and every bit as immediate as that is. If there's a difference, like if you would simplify this faster than you would simplify that's a mistake. You should simplify them both pretty much instantly. So you can subtract x from both sides. Notice this is still a question. Make sure that you do not drop the word is or the question mark. So notice Rumi is keeping those things. That's a good thing to do. So we have is minus y greater than y. And then we can move y over to the other side. We can add y to both sides. So that winds up being is 0 greater than 2y. And of course you can divide that in half. So is 0 greater than y, which we're not used to seeing the variable on the right and the number on the left, so we can just rewrite it like that. That's the question. The question is y a negative number? Aha, okay. But you still have this. You still have to deal with this. Like a lot of people pick B. If you're picking choice B, there's still this problem of you're not using this information. So, yeah, that's pretty much going to be the admonishment to everybody, not only everybody who picks C, but also everybody who picks B. Like this whole, if you are in either of these two groups, you didn't use the blue fact. You just didn't. You didn't have to use it. And I mean, you're going to have to use it. I mean, again, they're not going to supply you with things like this at random. Really, they will not. And I mean, if you go through the official guide, you can even just check this. You can go through your data sufficiencies that put conditions in the prompt and just do the problem and then just check to make sure that you use the condition, because invariably you're going to use it. So this is a thing. You have to use it. Yes, you do. Okay. So what do we do with that? I mean, notice that this applies to both of the statements. What that means that you should do is you should bring it down both statements. I mean, we know the statement 2 is going to be sufficient already, right? So because statement 2, y is definitely negative. So this is sufficient. But statement 1, okay. So we know, don't forget that we know that blue statement. We know that x is 8, and we know that x minus y is greater than 10. So we can substitute into there. 8 minus y is greater than 10. And then we can bring y over, and we can bring 10 over. And so then -2 is greater than y. Aha, so y is negative. This is sufficient. So we have D, like dog, both statements individually are sufficient. Any questions about this problem? That's not supposed to be H, it's supposed to be D, dog. Okay, there it is. And notice about, let's say, like 2/3 of the people here got this problem incorrect. And if you did get this problem incorrect, the takeaways here are going to be surprisingly simple things. In fact, the takeaways are pretty much not going to be any more advanced than don't pick things that are way too easy and make sure that you use all the stuff. I mean, really, the use all the stuff that's a better elimination criterion than a lot of people think it is. I mean, because the choice B is not unreasonable here, but again, if you pick that, at least you're simplifying the green thing. If you pick B, boy, but then you should be like, no, that's not going to be it because this blue thing is just hanging out here and I didn't use it. I mean, really, you're going to use the things every single time. You're going to use all the things, unless you're on the integrated reasoning section, where the purpose is that you don't use all the things anymore. But otherwise, you're going to use all the things. Any questions about this problem? So you can't really simplify the blue thing. I mean, simplify means that you actually simplify something. Like you actually wind up with something that is simpler than what you started with. I mean, the blue thing, you can sort of push things around if you want, but you're not going to get any of those to disappear. I mean, you're still going to have an X and a Y and a 10 in there somewhere. So there's no true simplifying of that. So given that there's not, it's not a very good choice efficiency-wise to do that because there's no obvious benefit. Whereas, like, simplifying something like this, there is a clear and present and obvious benefit to doing that, which is X is gone, and the issue is much more clear. But unless you can genuinely simplify something, or unless you have some other good reason to do that. Like, for example, if you move Y over there and get 10 plus Y, if one of the statements had 10 plus Y in it, then you would have a good reason to try to do that. But here, I'm not really seeing any good reason to do it. So efficiency-wise, I wouldn't do it. But you can. It just, I just don't, I guess I don't really see the point. Substituted X for 8 and 5. Yeah, you can also do that, right? You can also plug 8 into both this and that. You can do that, as long as you remember to not leave the 8 in there for the other statement as well. So yeah, you can do that, and you can plug in -20, and this will be a good thing to try on your own at home to see if you can get it to work. But absolutely, yeah, you can do that. As long as you said still simplify once you do that. It would probably be less efficient than simplifying this up front. Because notice that if you plug in those things, you have to deal with this equation twice. And if you simplify it at the start, you only have to deal with it once. And in statement 2, you don't even have to plug anything into anything because it's like, boom, it's negative. So that works, and it's good that you're doing something with it. But there's still a takeaway for you there in terms of efficiency. Like, this is the thing that it'll be always more efficient if you simplify this kind of thing first. But more approaches, if you have more ways to solve it, that's a win. So, nice. Okay, other questions? If not, we will move on to another problem. Let's move on to another problem. Let's see. How about this? Go for it. All right, I should probably wrap this up pretty soon. Um, And remember, I mean, every time I say, hey, we should wrap this up, there's like, oh, 8 people pick choices. I mean, which, remember, what you have to do in this test is you have to be very honest with yourself about when you are stuck and when you are not stuck. And if you are not genuinely making progress, then you should not keep doing steps. You should just pick a step. Okay, so what is... Okay, what they're doing here is, what you should notice here is you should notice a couple things. Notice first that this problem is very clearly visual. But there's no picture. Why do you suppose not? And I mean, one answer that people sometimes give to that is like, oh, they're trying to make it hard for us. But, and I know I've made this point 1,000 million billion times in other study hall sessions, but they really don't do anything specifically to just be jerks. So, because I mean, when you were in high school geometry, they probably had a couple of problems where they just like described a picture in words just to add some random element of difficulty. You know, like an altitude is drawn to the hypotenuse, blah 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 blah. But you know, they don't do that there. Like if there's a picture that they can give you, they'll just give you a picture. So, there's different cases, right? So yeah, like if it's a visual situation, but they don't draw a picture, it's probably because they can't draw a picture. It's not because they're being jerks. It's not because they're doing like, we're gonna like add this random element of difficulty to the problem. Instead, it's like, yeah, if this happens, you should think very carefully about multiple ways to draw the diagram. Right, because you have a distance between A and C, and then you have a distance between B and C, but the problem is you don't know how these things are oriented, right? Although we do, point C is kind of a hub in this problem, and we have relationships between both points and point C. So in terms of efficiency, it's probably most efficient to just think of every other point in relation to point C. So let's do that. Let's say that this is point C. And these are going to be different possibilities. There's going to be 4. I mean, I'm just making 4 dots just so I have to keep switching back and forth between a dot and the pen tool. But we'll see how we come to that conclusion here in a sec. The deal is the number line. So it's one-dimensional. There's no like up, down versus left, right. It's just left and right. If you want to make it just up and down, you can do that too, although traditionally speaking, number lines are left to right. So, and here we know it's left and right because this statement is phrased in terms of left and right. So the deal is that all we have is distances. I mean, we don't know where this stuff is relatively speaking in terms of left and right. We don't know where this stuff is at. So if this is point A is really close to point C, super close, like 5 units away. So it could be there, or it could be there. But then point B could also be either to the left or to the right. So well, that's 5 units, 5 unit difference. But then point B, so you could also put point B to the left, or you could put point B to the right. Do either of those. So point B could be over there, it could also be over there, and it could be over there, and it could be over there. That's all the situations. By the way, this is the kind of thing you should be able to do really quickly once you realize that it is happening. So this distance is 20. Like once you realize that there are multiple possibilities here, it shouldn't take you very long to construct these situations. In fact, this is a lot like even, odd, odd, even, odd, even, odd. It's like just making exhaustive lists of stuff like that. So if you have trouble making this exhaustive list pretty much immediately, then you should practice making this kind of exhaustive list, because it is the kind of thing you want to be able to just do. Okay, so that means that this distance here is this distance is 20 in all of these pictures. So now we take the statement, but notice all of this is up front. I mean, this is all at the beginning. This is before you use either of the statements, which is why it fits the theme of today. Before you use either statement, you do that. You draw all this stuff. Okay. So statement 1, the distance between point A and point B is 25 units. Well, that means that point A and point B are on opposite sides of point C. Because in the first drawing, B and A are only 15 units apart. So, and you don't even have to calculate that. You can just notice that it's less than 20. So, but that's so big. In the second drawing, they are indeed actually 25 units apart, and in the third drawing, they are also 25 units apart. But in the first and fourth drawings, they are not. So, in the second drawing, yep, C is between A and B. And in the third drawing, C is also between A and B. So this is sufficient. Notice it's not just one of the drawings, but it is sufficient. I mean, you still don't know what the drawing looks like as far as left, right. I mean, you could have a mirror image. Like third drawing is a mirror image of the second one, but not relevant because you have an answer to the question that you want. And this is another thing about data sufficiency that you should take note of. You don't reduce the possibilities to one picture, but you get an answer to the question in which you're actually interested. This is a hallmark of data sufficiency. And we've also done entire study halls that deal with this, but partial information is a thing. Like if they ask you a question like this, then you're probably going to get an answer to this and not much else. So there you go. Okay, and if you did pick the wrong answer, just think about why that might be. I mean, sometimes people just don't do as much work up front as they need to, but just figure out, because it's not going to be anything to do with number lines or distances. The problem will definitely not be those things. The problem will be something procedural. So statement 1 is sufficient. Statement 2, point A lies to the left of point B. So that still allows for 2 of these drawings. If point A is to the left of point B, you could be talking about this drawing, or you could also be talking about that drawing. In the first drawing, C is actually between A and B. In the second drawing, C is not between A and B. So that's 2 answers to the question. This is not sufficient. So we have A, alligator. In terms of takeaways you should get from this problem, I mean, there are a couple. The first is, and perhaps most importantly as far as generalizing from this problem, is this takeaway here. Like if they describe to you a situation that is clearly pictorial, visual, but they don't give you a picture, you should draw it, and you're probably going to wind up drawing more than one thing. So that's thing number 1. And in general, when they do this, you should hash out the possibilities up front. Like you not only think about multiple drawings, but actually think of them up front. Because the danger there is that if you don't, then after you've done statement one, it's going to be harder for you to conceive of drawings like this one that don't satisfy statement one. Whereas if you just throw out all the possibilities right up front, then number one, it's probably more efficient, it's probably faster. But also number two, you can do a better and more thorough job of generating possibilities because your thoughts are not being dictated by the statements. So, because once this is in your head, it's kind of hard to think of the possibilities where this is not true. And you're going to need those for the other statements. Any questions about this? Fire away. Otherwise, move on to the problem here. So we got two people typing things. Actually, wait a sec here. Two people typing stuff. What is typing? Can I repeat why the first case? I don't understand what you are asking me. I'm sorry. The first, it doesn't. The first drawing actually doesn't satisfy either statement. The first statement is satisfied by the second picture and by the third picture. So the reason why statement one is sufficient is because the question is this. The question is not what does the drawing look like. The question is, does point C lie between point A and point B? So if it's either definitely yeah, it's between them, or definitely no, it's not between them, then that's sufficient. Not sufficient means I can make a case where it's between them, and then I can turn around and make another case where it's not between them. So statement one only satisfies these two drawings, these two in the middle, and C is between A and B both times. So when you have statement one, even though there are two possible pictures, the answer to this question is definitely yes, point C lies between point A and point B. It settles the issue that you're interested in. I mean, you don't care which one of these is the diagram, but you care what the answer to that is. And that is an issue that is settled by statement one. So, new smiley face, if that makes sense. Person who asked the question. All right, sweet. Let's go to another problem. Let's do it. How about, let's see here. How about, see if you can answer this in this next one. I'm going to give you 45 seconds to answer it. Tell you what, let's say 48 seconds. Why not? For fun. You're going to have 48 seconds. There you go. Okay, give me an answer. We'll talk about why I'm giving you 48 seconds in a second, but you have questions off the screen. So that was the time that you had, but go ahead and give me something. And I'll put the question back and then we can talk about it. Not the kind of judgment that you have to make in advance, but again, the theme of today is work to do up front. And if you do the thinking, it's not even work, I would say, per se, but go ahead and guess something to this. There's still about, like 10 or 12 people who have picked one. I want you to pick an answer first. And then I'll put it back on the screen. A lot of people who didn't pick one. Go ahead and make a guess. All right, some people are just going to take their ball and go home. All right, so this. Back to what we're doing here. I mean, okay, so basically each row of chairs has the same number of chairs. What is that telling you about the arrangement of the chairs? It means that the arrangement looks like a what? Yeah, they're in a rectangle, right? So they're in a rectangular arrangement. And then, like, okay, the number of rows, which is the same thing as the number of chairs in a column, is one less. So it's like an n by n minus 1 rectangle. So it measures n by n minus 1. Well, so you know what that means, right? Like, in other words, it could be, okay, it could be 1 row of 2 chairs, it could be 2 rows of 3 chairs, it could be 3 rows of 4 chairs, etc. And this is all of the possibilities that you could have. So think about what this means. This means if I tell you how many chairs are in a row, that's sufficient. If I tell you how many rows there are or how many chairs are in a column, that's sufficient. If I tell you basically anything at all, that's going to be sufficient. Because all of these have different numbers of chairs in every dimension, right? So basically, if you just think about this, if you are given basically any piece of information at all here, if you are given any numerical dimension, then sufficient. And this is the kind of thing you should absolutely think through up front. Because this is not something where there are weirdo exceptions to anything. I mean, this is not, you know, oh, I got to think about negatives or think about something like that. I mean, this is near rows of chairs. So really it has to be one of these integers, 1 by 2, 2 by 3, 3 by 4, blah, blah, blah. So good. So meaning, I mean, 72 chairs happens to be 8 by 9, but the point is you don't even have to bother. Like, let's say instead of 72 chairs, let's say that I gave you, I don't know, let's say that I gave you about 45,582 chairs. I mean, the point is that this statement would still not need to take you any longer than the original one. In fact, it might even take you less time because you realize you wouldn't have to waste the time. Like, the deal is this would be sufficient. Because if you just think about this pattern of possible arrangements of chairs, I mean, you probably can't just look at that and tell what it is, but this is going to be only one of these, clearly. I mean, because every single one of these arrangements is bigger than the one before it and smaller than the one after it. So there's going to be exactly one of these that has 45,582 chairs. You don't even care which one it is. So it's going to be something that's going to work. They gave you 72 chairs. Ironically, the fact that it's a smaller number might make more people waste the time to actually figure out the precise dimensions of the matrix. You don't have to. It's a sufficiency problem. You just have to be like, dude, there's one size. Done. End of story. Smiley face if that makes sense. And if it also makes sense with 45,582. Okay. Smiley. And then after one chair is removed from the last row, well, this means that if you don't remove that chair, then there are 18 chairs in 2 rows, which means there are 9 chairs per row, and so that's sufficient. And in fact, you don't even need to do this much reasoning, because as soon as you see this, you can be like, aha, they're telling me how many chairs are in a row. So if this was, instead of 17, if this was like 286, or sorry, that's an odd number, if it was like 285 or something, then you'd be still, boom, sufficient, because you know how many chairs are in a row. And then it's going to be one of these again. So the point is, if you did any calculating here, because 48 seconds is plenty of time to read this problem and understand what the words mean. You know, that's not so crazy short that you have to rush through the words. I mean, even if you're reading these words very, very slowly, you can still get through them in 20 or 30 seconds. So if you didn't finish this problem in 48 seconds, think about why not. Think about what you were doing that had adverse effects on efficiency. And then don't do it next time. All right, any questions? Go ahead and type away. Now we'll jump to another problem here. How about this one? For it. Remember, the theme of today's workshop is work that you can do up front. You know what that means, right? That means that you should do work up front. Yes, you're here. Also, remember we said about partial information and goals and things like that. If you already picked the answer, you're wrong. Both of you. No. Okay, let's just public service announcement here, guys. I mean, okay, let me just tell you something right now. If you finish a data efficiency problem in like 10 seconds, you're wrong. Period. I mean, it's not going to work like that. But let's go back to this problem that we saw. Where was it? This one. Okay. I mean, remember, really, if you are doing something that is way too easy and you are ignoring stuff, then you're wrong. Way too easy. Ignoring stuff. Ladies and gentlemen. If you're picking answer C to this problem, yeah, don't do that. I mean, if you don't have to think about this, then you're dead. So if you're one of those people who answered this question in the first, like, 10 seconds, try again. Okay, it's been kind of a while. It's been sort of a bit. Let's pick a thing. If you have to guess, then guess. Just remember, there's no reason to think you have to solve every problem in the world in 2 minutes, because 2 minutes is an average. Average does not mean maximum, ladies and gentlemen. I mean, if you think you have to solve every problem in 2 minutes, then you're not really going to do that well on this exam, because basically when a problem is long, you're just not going to finish it if that's what you're trying to do. Because averages are averages. Averages are not maximum values. I mean, if you're managing time well, you're going to have just about as many problems over 2 minutes as under it. So don't be thinking that 2 minutes is some kind of upper limit, because it's not. All right, let's make a guess if you haven't picked an answer yet. Let's pick a thing. Claire, Herman, Harris, Sydney, Rob. Okay. No, not going to answer it. All right, let's talk about it. I mean, first let's talk about if you are picking C here, because you shouldn't pick C. That was the point of the interruption at the beginning, was that you shouldn't be picking C in this problem. Because okay, I mean, if you write that first thing as an equation, if you do, then the difference between Mary and Jim, so Mary is the highest, so this is M minus J, and that's 2 times Mary minus K. Okay, so if you pick C, if you pick C, then you can just plug in J is 30, and you can just plug in K is 40, and then you get M, and you have all 3 numbers. So I mean, that was the point of this whole commentary about if you don't have to think about the average, then you're dead. I mean, if they're asking you for the average, they're going to be doing that for a reason. And the reason is you're not going to find the whole list. You pretty much just be assured of that right up front. Do not expect to find the whole list. Do not expect. In fact, you should expect not to find the whole list. And I mean, once you get used to the way these problems work, you'll know this. I mean, you should expect not to find all 3 numbers. I mean, if you're a veteran of these data sufficiency problems, you'll know that this is how they work. I mean, because think about it from the point of view of the question writers. Like when you do these, you should stop and think about. That's basically the idea, yeah, in the chat box there. You should stop and think about what would motivate somebody to ask this question instead of saying, hey, what are the 3 salaries? I mean, if someone says, what is the average of the 3 salaries? I mean, same thing with this problem of the number line, right? Like this problem, where's the problem of the number line? This thing right here. I mean, when they ask this kind of question, I mean, this question is so oddly specific. So whenever they ask a weirdly specific question, you should think about why are they asking this question? Because the answer is pretty much always going to be that is something you can find, even though you cannot find all the things. Like in this problem, you found that point C does lie between point A and point B in statement 1, even though you don't find the specific picture. There are still 2 pictures. But you find out the answer to this. So in this problem here, you should suspect that you are going to find the average, but not the whole list. So if you think about this, I mean, there's a couple ways that you can realize that. One person says you don't need algebra if you are visually oriented enough. That's probably true if you are visually oriented enough. Because you can interpret the original statement visually. This original statement, that thing. Because you know that Mary, if you put these things on a number line, then you know that Mary is on the right because Mary's salary is highest. And so then, if you want to visualize that statement directly as given, so let's put Mary here. Then we know you've got a difference between Mary and Kate, which is a smaller difference. So this is the difference between Mary and Kate. This right here. But then you have the difference between Mary and Jim, which is twice as big as that, exactly twice as big as that. So it means we got to take that difference and we have to, let's not make it that big, just kidding. Take that difference and let's just double it up, right? Twice the difference. So that means you got a point over here, which represents Jim. It's actually a little farther over there. This is a little bit longer. I feel like something like that. So that means the K is the halfway point. So, aha, K is the average. Yes, indeed it is. And so that means that statement 2 is sufficient. So you can do that. That's one way of realizing that K is the average. If you didn't catch that, then another thing that you can do is you can, there's actually a bunch of algebra that you could do. What did you have in mind, Romit? Okay, so that's the statement here. And then all right. So you're bringing everything over to one side. All right, I like this because this is not random, right? There's a goal here. I like this. This is good. This is followable. Because like sometimes people post these algebraic solutions that are admittedly they're ingenious. Like a lot of them are very creative and interesting, and they are things that I would never think of in 1,000 million years. But the problem with things that are like that is that people are not going to think of them. So, but this is cool because this is very goal oriented, and this is something that people could totally do, right? Because the goal here is to isolate the expression m plus j plus k over 3 because that is what we want. So, yeah, we want m plus j plus k divided by 3. That's the average. So, because this step might seem a little bit mystifying at first, because in effect we are sort of unsimplifying stuff here. But it makes perfect sense because you want to create m plus j plus k on one side of the equation, and this is a way to do that. Absolutely. So therefore, m plus j plus k over 3 is going to be k. You can also do that, and then you can realize that the average of the 3 quantities. Well, so now you have the same sort of observation that you have here, that k is the average of the 3 quantities. And this is not beyond craziness. I mean, this is something, as long as you have the clear goal of getting m plus j plus k on one side of your algebra, then, okay, let's talk about testing cases. That is definitely a thing that you can do. You just have to know how to do it. I think I see where the problem is, but first of all, everybody follow this algebraic approach. So once you find out that K is the average, then Jim's not going to tell you this because we know that K is more than 30,000, but it could be anything, right? Like in statement 1, it could be 30,000, 30,001, 30,002, or it could be 30,000, 130,000, 230,000. So we don't know. In statement 2, though, is sufficient. Even though I still don't have J or M, because you know what, I don't really care. I just care about the average, which happens to be K. Yeah. All right. Smiley faces, that makes sense. As x minus 1 and x minus 0.05 would not be in the middle of those two. I think you might mean 0.5 and not 0.05. But you are making up a number that's not there. I mean, how would you know that this difference can be represented as 0.5? I mean, if you're going to do that, you would have to call them like x and x minus d for difference, and then x minus 0.5d. Because the amount of that d is still unknown. Like the amount of the difference is not 1. I mean, you would have to, if you're going to do that, you have to define another variable for that. Let me know if that makes sense. Like if you call this x minus 1, you are saying that Jim's salary is exactly $1 less than Mary's salary, which we don't know that. So you would have to define another variable, and then you would get 2x minus d over 2 instead of 2x minus 1. Let me know if that makes sense. Yes, no smiley face, not smiley face. All right, great. Let's talk about plugging in values. Let's talk about testing cases. Let's take this to a blank page. So here's the question. The question is this. Let me tell you where the problem is with this. The problem with this is that this is singular. You see why that's a problem? Read, do you see why that's a problem? If not, can someone else explain it in the chat? Why should that not say a value? Okay, Rishi's typing, which is good. That's what we want. She's not typing anymore. So yeah, you got to plug in multiple values. There it is, right? Because again, the point of data sufficiency is not, there's never like one thing that you plug in, right? The point, and this also addresses the question that Tia has asked here, which, I mean, okay, you have the right idea here, although you might want to think about goals. Like there are basically two possibilities here, which are sufficient and not sufficient. Sufficient means that only one answer is possible. And not sufficient means two or more answers are possible. Okay, now as far as which one of these is the goal, that's going to depend on how you're approaching the problem. Like if you're doing algebra, then you are actually trying to prove that something is sufficient, because that's what you algebraically, right? Because algebraically, you're trying to get stuff to drop out and leave you with a pretty number, and that's it, right? So if you do algebra, this is the goal. In other words, you try to get everything to drop out and leave a number. See, on the other hand, if you're testing cases, you can't. That's not the goal anymore. Because if you're going to plug in numbers and you're going to see what happens when you plug in numbers, you can't plug in numbers and try to make something not happen. So if you plug in numbers, like if you test cases, this is the goal. You see whether you can get two things to happen, and then if you fail, then that's sufficient, right? If you actually make two things happen, then not sufficient. And if you fail to make two things happen, in other words, if the same thing happens every time you test a case, then you basically just give up and you say sufficient. If this is not sufficiently clear, then there are plenty of study halls. I think there's like 4 or 5 of them at this point on the topic in the archive session. Check out the archive session on testing cases in data sufficiency. There are entire study halls that are just dedicated to that. So I think there's 4 or 5 of them at this point, but that will definitely help you with straighten this sort of thing out. So it's not a value. It's you have to plug in a whole bunch of different values and see what happens. So multiple values. And then if you can make 2 different answers happen, then not sufficient. So let's talk about that, right? So like in statement 1, here's our equation. We have and if you're going to be plugging in numbers like this, you're probably going to plug into an algebraic equation. So Mary minus Jim is 2 times Mary minus Kate. Okay, so statement 1, you have Mary minus 30,000 equals 2 times Mary minus Kate. So we can rearrange that. So M minus 30,000 is 2M minus 2K. So therefore 3M. Yeah, so, no, sorry, subtract it. Minus M minus 30,000 equals minus 2K. So M plus 30,000 is 2K. So M is 2K minus 30,000. If you solve for K, then it's going to be a fraction, which is not anybody's friend, really. So you can plug M, and then you can find K, and then you can find the average of all 3. You can do that. And then testing cases. But you got to know that you need to test multiple cases here, which is what you pretty much have to do when you test cases. So if Mary, you got to plug in things that are more than 30,000. So, and actually in this case, sorry, it would be plugging in K and finding M, because the M in terms of K. So K is still more than J. If K is 40,000, then M is 80,000 minus 30,000. And so that's 40,000. 120,000 divided by 3. And then if you plug in like 100,000 for K, then M is 200,000 minus 30,000, which is a whole lot more than 40,000. So I got 2 answers. That's not sufficient. You could plug in for m. I just don't want to deal with fractions. Like if you plug in for m, then k is going to be half of m minus some number. And I would just rather not deal with fractions than deal with fractions. So, but if you do it, you should try that as well. Like when you review the problem, you should absolutely try every possible angle on it. So that's not sufficient. And statement 2. So now we have a number for k, but not for j. So this is back to being j again, and now this is 40,000, and now it's statement 2. So it's m minus j is 2m minus 80,000. So if we bring m over to the other side, and then we bring the 80,000 to the other side. There it is. Okay, so plug j, find m, and then find j plus k plus m over 3. Remember, j is got to be smaller than k because j makes less money than k does. So if j is 10,000, then m is 80,000 minus 10,000. And then that is 10 plus 70 plus 40 is that. If j is 20,000, then m is 80,000 minus 20,000. And it is still 120,000 over 3 is 40,000. And you're just going to keep getting 40,000 over and over again. So this is sufficient. And the point is just that you would try enough cases to convince yourself of the pattern. And remember that data sufficiency doesn't have fake patterns. So once you get 120,000 a couple times in a row, you should be like, dude, it's going to work out like this all the time. Because they're not going to get fake. They're not going to throw fake patterns at you. I mean, basically, if you see a pattern, it's going to be real. So notice, though, you could also, once you get to this, you could also do algebra at this point, too, if you were not as forward-thinking with the algebra as Robin was. Like, you can also do algebra here. Right, because you're doing j plus k plus m over 3. And for statement 2, we know that k is 40,000. And we know that m is 80,000 minus j. So we can actually just plug those things in. So that's j. And then k is just 40,000 in this. And then Mary is 80,000 minus j. Oh, hey, look, the j's are gone. And so that's a single number, which makes it sufficient. So, and you don't even have to bother calculating what the single number is. There's so many ways that you can go. I mean, you can, basically you can jump off of one horse and onto another horse at any point during this race. I mean, if you think you're on your way to testing cases, but then you see something that you could algebraically plug in, then you should jump off of that and you should do the algebra. Or you should just go through a testing case. Like, as long as you're doing something, then you're going to win. I mean, it's just, you just don't want to be doing nothing. You know, and it goes back to my favorite pieces of advice, which are do stuff and don't not do stuff. If you've watched enough of these study hall things, you've probably heard me say that more times than you would want to. Do stuff, don't not do stuff. So, absolutely. Got a couple people still typing questions. Let's see what those are. If they're not big questions, we might be able to do it super quick thing. All the archives are, you just go to the there's only one Thursdays with Ron webpage. You go to it and you scroll down and you will find the archive sessions. You scroll down endlessly and there are like a billion zillion of them. Okay, I am on a sort of tight schedule, so the discussion of this problem is going to have to be very, very fast, but we can still put it on the board and do it. So, thanks for the link. Appreciate that. You can probably tell when you look at this problem that this is not the kind of problem that should take 2 entire minutes. This is the kind of problem that you should finish in less than 2 minutes, even if you're guessing. Because remember that this whole 2 minutes thing, it's just an average. I mean, if you're doing a long problem, it's okay if it takes more than that because it's a long problem. It's probably longer than average. But the converse of that is if you're doing a short problem, then you should not stare at it for 2 whole minutes. Like a problem like this, you're pretty much done in 1 minute either way, if you're being honest with yourself. So give it a shot, and we will have a very, very hurried discussion of it afterwards, and then we will finish on time. Interestingly enough, the first 3 people have 3 different answers. Go for it. Let's take an answer to this thing, and then we will have a very fast discussion of this because I got to run pretty much right when the bell rings, so to speak. But if you don't yet have an answer, then please pick one. Okay, and remember, this is the Work Upfront workshop, which, I mean, don't forget what the topic of the workshop is. So it's the kind of thing that you can do work up front with. Here it's conceptual work. Like this is not the sort of thing that you would want to try to approach algebraically because there would be so many cases, right? Like you would have to worry about all these different combinations of signs. But basically remember that, what you want to remember here is that the absolute value, or modulus, if you are from some countries, I think you call it modulus instead. The absolute value, or modulus, is like basically how big the number is, like the size of the number, without worrying about sign, without worrying about plus or minus. So like, minus 14 and plus 14 are the same size is basically the deal. So what this means is that the size of x is the size of x bigger than the size of y, is what this is saying. In other words, is x plus or minus bigger, and y is plus or minus smaller, is another way that you can think about that. It doesn't matter what the sign is, it just matters what thing's bigger than the other things. So in distance of x from 0, you can also think of it as, if you are more number line inclined, you can also, instead of size of number, you can also think of it as how far away from 0. You can also think of it that way. So, yeah. And if you think about what makes a square bigger than another square, if this is true, then, because I mean, remember that the squares become positive, so or it's rather non-negative, because if it's 0, then it's positives. But this means we don't know the signs. They could be anything, but we know that x has to be bigger than y. We know that x is plus or minus bigger, and y is plus or minus smaller. Because that's the way you're going to get squares to be bigger than other squares. And again, if this is not clear, probably the most important takeaway that you can get from all of this is that if this is not clear, then you should play around with numbers, and you'll see the pattern fairly quickly. I mean, the point is to just not sit there and wonder about it. The point is just to mess around with numbers and investigate. Y can also be 0. Like plus or minus smaller does include the notion of 0, but yeah, right. So, absolutely, right. So, statement 2, the problem is, see, if you have negatives, the sizes are reversed, right? Like, if you have, in other words, like, if you positive big would be bigger, greater than positive small, but negative small is actually greater than negative big. If this is too abstract, then you can just generate numbers. You can test cases. And then just throw them into that question and see, right? So if x is, you do have to make x bigger than y. So that has to be preserved. But then you just come up with numbers to do that, right? So if x is like 2 and y is 1, then 2 is greater than 1. Yes, it is. But if x is like minus 1 and y is like minus 2, then that's 1 and 2, no. So not sufficient. There you go. All right, I get a jump here in a sec, but if there are any super amazingly, incredibly fast questions, I can try to tackle them. If not, then we're over time. But thank you for, oh yeah, so it's, well, sufficient. Not sufficient, because this means sufficient. So that means A alligator overall. So if you take -1 and 0, then that'll be another case of this. So no, if you take -1 and 0, then this is still 1 and this is still 0. Then this will be yes every time for statement 1. So try it out. You might be forgetting to take absolute values up here. So, but something is, yeah. All right. Cool. All right, ladies and gentlemen, turn off the recording. Good afternoon, good evening, good night, good morning.